Hi students, today we will discuss the moment of inertia or different type of problems. No, already I discussed part 1 and part 2 on the moment of inertia. Please go through it and so that you can understand very clearly. So different model of questions no will do in this moment of inertia. So first of all, let us go for the basic one. No, so question 1, right? Let us see here. I will take 2 point masses. Be careful now, these are the 2 point masses m1 and therefore it is m2. These two are separated by some distance, point masses now. Now what we can do now, we want to rotate this one now, so it will be exactly at the midpoint, right? So that means we are rotating the axis of rotation passing through the midpoint, therefore perpendicular to the line joining between them. So therefore simple thing now we can write down r by 2, this also r by 2. So you can rewrite it as moment of inertia, you can write down m1 into r by 2 whole square plus m2 into r by 2 whole square. What you can write it now? Therefore r square by 4 into m1 plus m2. Clear? Right? Now this is a simple question. No? Now we will go for a same type of question. Suppose here m1 is a 1 point mass and another one more is a point mass m2 point mass, and we want to find the moment of inertia of an axis passing through the center of mass. Therefore center of mass of an axis passing through the center of mass. First of all, you have to calculate what is the center of mass distance. No? So therefore this distance is r1 and this distance is r2. Let us calculate this distance now. If you want to calculate center of mass now, if you want to calculate the center of mass, you have to choose this is your axis now. Therefore this is your axis, then you can calculate now x cm. Therefore this we can write it as like a r1 is nothing but m1 into r1 plus m2 into r2 by m1 plus m2. This is at origin now, m1 into 0 plus m2 into r, distance is totally r, divided by m1 plus m2. So what is the r1 distance now? m2 into r by m1 plus m2. Clear? Right? So here similarly r2 we can rewrite it as m1 into r by m1 plus m2. Clear? So now we want to calculate moment of inertia of an axis passing through the center of the center of mass. No? Now we got it as r1 and r2, so we can write it as very simple. So I is equals to m1 r1 square plus m2 r2 square, right? So what you will get it now? This m1 into r1 is how much now? m2 into r by m1 plus m2 into whole square plus m2 into, so r2, therefore m1 into r by m1 plus m2 into whole square. Clear? So therefore you can just solve this one, no? So you can get it now easily. So we'll solve this one, no? That is here just mathematics, m1 m2 square into r square by, therefore m1 plus m2 whole square, no? Same thing, therefore m2 into m1 square r square totally, therefore m1 plus m2 whole square. Clear? So then we can rewrite it as here m1 m2 into r we can take it common, m1 m2 into r also we can take it common. So here m2 gone now, so one m2 is present, one r is right, r square we can take it common, r square. So here m2 plus m1 it will be remains no by m1 plus m2 whole square. Therefore this one will get cancelled out. So what will be the moment of inertia if an axis passing through the center of mass? No, therefore I is equals to m1 m2 by m1 plus m2 into r square. This is your moment of inertia. So sometimes some of the questions no we can solve. This is nothing but a reduced mass. We will call it as like a reduced mass. So we can solve directly, right? Most of the situations, no, if any two particles are there, so we can take it as like single mass, no. that is nothing but a m1 m2 by m1 plus m2, that is nothing but a reduced mass into r square. In this way you can solve it, no? Okay, these are all slightly simple problems, no? Then we will go for one more important concept, right? So this is one more type of problem, no? Now we'll see, now the confusion will comes, no, in this problem, right? Let us see here, no? Suppose same type of question, what I will do, I will take one sphere, I will take one sphere, and therefore these two are attached with a massless rod. This is nothing but a massless rod of length is L. Now this, right, these are connected at the center of this one, no? This is your radius r, and this also radius is r. Its mass of this one is m, and mass of this one is m. Now we want to rotate this one now at the exactly the midpoint onto this one, no? This distance is L by 2, and this distance is L by 2. Right. We will calculate the moment of inertia of this one, no? These all are solid spheres. Solid spheres. Be careful, no? Here, like our previous problem, no, we cannot take it as like a m1 and all this one, no, because these are like a therefore some are huge masses here, no, right? So what you have to do, no? Therefore here you have to apply the parallel axis theorem. You have to apply. So that means this is your one sphere. This is the one sphere is there. So therefore here you want to rotate it now. This sphere, where you want to rotate now? Here you want to rotate. Therefore this sphere, the sphere it will come like this. So for this one now, what you have to do? You have to take like a one, right? This is nothing but a IG. IG what? Therefore for the solid sphere, no, what will be the IG? That is moment of inertia of an axis passing through the along the diameter, no. So this IG, that is nothing but a 2 by 5 mr square. This already I did in the second part, right? Please go through it. So here I want to calculate. So this is the moment of inertia. So here these two are parallel axis, no? Therefore this distance is how much, no? Therefore L by 2. Clear? Here you have to use a parallel axis theorem, right? So here we'll apply parallel axis theorem to rotate one sphere of this one, no? So here I is equals to so here therefore IG, therefore 2 by 5 mr square plus m into L by 2 whole square. So therefore 2 by 5 mr square plus m L square by 4. This is the moment of inertia to rotate the one sphere. Like that, therefore here massless rod is we are considering like a massless onto this. So therefore we are rotating this one now. Like that, if you want to rotate the second one also, therefore 2 will be there. Total moment of inertia. So total moment of inertia, it will be I is equals to total of this one now. Therefore 2 times of your, this is your I there, whatever you calculated now. So therefore 2 times into, therefore you got it as 2 by 5 mr square plus ml square by 4 now. Clear? So multiply it now, you can get your answer. Therefore 4 mr square by 5 plus, therefore multiply it now, ml square by 2. This is your moment of inertia of these two spheres connected by massless rod we are rotating now. Suppose if you are considering the mass of the rod also, if you are considering, then also you need to, not only the spheres are rotating, you need to rotate this rod also. Therefore that is ml square by 12, that also you have to consider onto this. Clear? So like this you need to find the problems, no? Let us see. So some more combinations, no? Now we'll see one neat question, no? This is your neat question. So therefore here there is a one ring is there. This is one ring, and this is one more ring, and this is one more ring now. Clear? So here now we want to, these are the three rings of mass m and radius is r. So we want to rotate along this axis now, I. So here this ring is there, it is the passing through the diameter of this one, no, ring. Therefore it will be for this one, no, that is nothing but a mr square by 2 along this one, no. This how it is there now, this is one ring, therefore here it will be passing through this one now. That means how it will be like a tangent and parallel to this one now. Tangent and parallel to this one means what? Mr square by 2 plus mr square. Therefore 3 by 2 mr square. Therefore these two are there, no. therefore 2 into, therefore 3 by 2 mr square. So what you can write now, this is 6 plus 1, 7 mr square by 2. This is your moment of inertia, so of this combination. So like this you can try. So if all are disk, no, therefore these are the disk, no, like this is arranged, and these are the spheres, solid spheres, no, and there are, these are the shells, no. So you can calculate the moment of inertia of all these parts now, right? So whatever the moment of inertia of the disk, no, I already uploaded in a second video. Please part 2. So please go through that one now, right? So again one more thing, just a simple extension of this one, no. So this is one disk is there. Okay, we can do this one more question, no. This is a disk, right? So this is one more disk, no. This is one more disk, and here also one more disk, no. Now how we are going to calculate it now? Right, the moment of inertia, it is like this, no. Right, here disk, no, this is passing through along the diameter. Diameter means what? Mr square by 4. Here two disks are there, no. 2 into m r square by 4 plus, how this disk is there now? Again disk is like this. So here axis passing through this one, no, tangent and parallel to the plane. That means this is mr square by 4 plus mr square. That means 5 mr square by 4. These two are there, no. 2 into 5 mr square by 4. Therefore here 2, 10, therefore 12 mr square by 4, 3 mr square. Students, so we'll see some more questions, no. See, in this problem, no, therefore we are using the disk, no. You can do for like a rings arranged like this, no, and the spheres, solid spheres, no, and shells, no. Therefore you can calculate as a moment of inertia of all these one, no, exactly the same. So what are their moment of inertia? I already discussed in the part 2 video. And we'll see one more important question, no. So this is one of your JEE main question, right? Let us see here now. Therefore here there are disks are there, no. How the disks are arranged now? This is one disk, no. So there are 3 identical disks are there, no. Therefore here this is one more disk, no. So here this is one more disk. That means it is like this. That means here, so here this is disk, assume that this is a disk, no. This also a disk, this also disk, like this is arranged now. So now what we want to do now? We want to rotate at the midpoint of this. So these are the 3 identical disks, no. 3 identical disk. So therefore whose mass is m and radius is r. So therefore here we want to rotate it now. Clear? The moment of inertia. So for this rotation, no, therefore here there is a disk is rotating, no. Therefore for this disk, no, so this disk, no, therefore for this one, no, this is 1, 2, 3, right? So this is first one, no. First one, what you will get it now? mr square by, so 2. This is first one now. But the second one and third one, how we are rotating now? We want to rotate this disk, no, at this point. That means, so at this, like this, we want to rotate it now. So here it is not passing through this one, no. Here we are passing. That means you have to use parallel axis theorem compulsory for this one, no. So this is one disk is there here, no. This is one disk. So here you want to rotate it now like this. So now you can take it. This is your IG. Therefore this is passing through along the diameter of this one, no. Diameter means what? Mr square by 4. This distance is how much now? This distance is nothing but a radius is r, right? This mass is m, this distance is r. So you can use parallel axis theorem. Therefore IG is nothing but a mr square by 4, and this rotated, no. Therefore it will be mr square. How much it will be? 5 by 4 mr square will be your moment of inertia. So therefore here we are rotating like this. Clear? So this also we are rotating, no. Therefore it will be 2 times of, therefore 5 by 4 mr square will be your form. Therefore we can cancel it, no. So what you will get it now? I is equals to mr square by 2 plus 5 mr square by 2. Therefore 6 mr square by 2. Therefore it will be 3 mr square will be the moment of inertia of this one. Suppose in this question only, what you can do? We can calculate. We can ask what is the radius of gyration. Most of the students, what they will do, they will divide with m. No. So why? Because here not a single mass is not there, no. There are 3 disks there, no. Therefore total moment of inertia, I mean radius of gyration, no. Radius of gyration is nothing but I by therefore 3m. So I is how much now? I is nothing but 3m r square by 3m. Therefore this get cancelled out, no. So radius of gyration is r. Clear? In this way, you should be very careful while solving these type of problems, no. Now we will see one IIT advanced question, no. Here they are given as given 7 identical disc, no. Therefore circular disc, no. So whose mass is m and r. How they are arranged now? Like this. So therefore here okay. So the diagram, right, let us take this one, no? So here three right. So there are 7 identical rings are there, no. It is connected like this, no. Now we want to calculate the moment of inertia. So if an axis passing through at this point now, therefore at point P, let us write down, this is a point P. How? It's like a perpendicular to this point. Clear? So you are understanding? We want to rotate all this one now. Clear? So therefore how to do this type of questions now, right? No need to panic onto this one, no. It's a very simple concept, no. Let us see here. So first of all you have to calculate Ig. What is Ig now? So this for this totally, therefore the center it is passing through this one. This it will be your Ig. Clear? So this is your Ig. But to calculate this Ig, not only we are rotating this disc, no, this disc also we are rotating. Therefore, so this is first one, no, that is nothing but mr square by 2. This for this one, no. For remaining other things, no. Therefore that means this disc is there, no. This disc, what you are doing now, we have to rotate at this point, this disc. So how to rotate now? Like this disc, no, we have to rotate it. Clear? Now, so how to use it now? Therefore here also this it will be the Ig for this part, no. So we can use a parallel axis theorem here. So I is equals to, we are rotating this one. This is your Ig, that is nothing but mr square by 2 plus, therefore what is the perpendicular distance here now? From here to here. Here is the distance. What is the distance now? Radius r. Therefore 2r will be your answer. Therefore here m into 2r whole square. Clear? So that is nothing but mr square by 2 plus 4 mr square. Therefore 8 9 mr square by 2. This is for 1 now. For 1. Like that, how many are there? 1, 2, 3, 4, 5, 6. 6 are there. So that means it is 6 into, so 9 mr square by 2. Clear? So here Ig, right. Therefore it is 2. 9 6 are 54 plus 1. Therefore it will be 55 mr square. This is your Ig for this total system. But I don't want this one now. What I want to calculate here now. Therefore, here, so therefore again you can use the parallel axis theorem at this point, no? You can use parallel axis theorem at this point. Therefore, therefore we got this Ig and this is now. Therefore, here what you will get it now? I is equals to Ig plus md square now. Ig 55, so mr square by 2 plus here. What is the distance here now? Distance is nothing but this is r and r. Totally 3r. Total mass is how much now? Total mass of this one now. So totally it will be 7m. Therefore 7m into 3r whole square. Clear? So what you will get it now? Therefore 55 mr square by 2 plus. So therefore here 7. So 7 9. Therefore 3 square it is 9. So it is 63. Therefore 63 mr square. So you can multiply this one, no? Therefore 55 mr square plus multiply to this one, no? Therefore this is 126 mr square by 2. 126 means how much now? It will be therefore it is 11 1, therefore 5 6 7 8. So 181 mr square by 2. So this it will be your moment of inertia of this total system. Like these questions, no, you can expect in the examination now, right? Clear? Right. So one more important model question, no, we'll see it, no. Listen. Now let us take this is also JEE main question. JEE main. Now let us see. Right, there is a one sphere is there. All right, there is a one disk is there. This is one disk, no? Okay, so this is one disk of mass 9m of radius is r. Okay, what is the disk now? Disk mass is how much? No, 9m, not m, no, 9m, radius is r. Therefore, upon to this disk, now what you are going to do? We are going to cut the one small part of this. So small part here we are going to cut it now. This much part now, what we are doing now, we are going to remove, right? So what is the radius of this one now? Removed part radius is nothing but r by 3 radius part of this one now. So remaining other radius is how much now? This total is r. So r minus r by 3 means nothing but so therefore 2r by 3. This is your part of this. Therefore this much part now, what you are doing now? We are cutting onto this. Clear? So if you are cutting onto the cutting of this cutting of this this part, no, how to calculate the moment of inertia? Moment of inertia we have to calculate at this point. So moment of inertia. So what is how to calculate now? Very simple formula I will tell you. So moment of inertia, it will be equal to cutting part, no, moment of inertia for the complete body, therefore whole body minus moment of inertia of a removed part, right? So, but to apply this one, no, compulsory axis of rotation should be the same for both of this one. No. That means for removed part, no, and for whole body, the moment of axis of rotation should be same, right? So first of all, let us calculate what will be the for whole body before cutting onto this. What will be the moment of inertia for complete body? Therefore, simple thing, whole body. So it will be equal to this is a disk, no, diskness nothing but mr square by 2, but total mass of this one how much, no, 9m into r square by 2. So this is your whole body moment of inertia. Now we want to calculate this one. First of all, you have to calculate how much mass is there. So removed part, no, therefore we are removing from the same part, no, that means same density it will be there. Density it will be the same. Clear? So because same material only, no, therefore the removed part mass, no, we want to calculate the mass of this one. No. Mass of this one is suppose m. We want to calculate. So how to calculate it now? Removed part mass, no. So this removed part density and this mass, this density, it will be the same, right? So mass of the density means what? Therefore removed part and density of the whole body, it will be the same. So therefore mass of the removed part is small m by total volume of this one how much now? This area, that is nothing but pi into r by 3 whole square into thickness. As on the area of cross section and thickness of this. Clear? The total body mass is how much now? 9m total body mass now. What will be the total volume now? Pi r square into thickness is t. Clear? So what I will get it now? Therefore you can cancel it onto this one. No? You will get 9m. Therefore 9 into small m pi r square into t. So 9 capital M into pi capital R square into t. So get cancelled out. Therefore 9 also get cancelled out. So the mass of this sun is nothing but a m. Right? So mass of this removed part, no, it is m. So the total body mass is how much? No, 9m. Clear? So total body mass is 9m, but removed part mass is nothing but a m. Okay, now I got it now. But I want to calculate the moment of inertia. So, but where you have to calculate moment of inertia for this part? No, here you have to calculate. Therefore, that means this is the one removed part is there. Here you have to calculate the moment of inertia. That means how to calculate now? This is nothing but a parallel axis theorem. So here this, you know, these two are the parallel axis. So this it will be your Ig. Clear? So therefore here Ig, what you can write it now? This mass is m and radius is r by 2. Therefore it is a disk, no? Therefore m into r by 2 whole square, sorry, r by 3 whole square by 2, no? What you will get it now? Mr square by 9. Therefore mr square by 18. This is your Ig. Ig now. Therefore what you want to do now? We want to calculate the moment of inertia of the removed part here at the center of this one, right? So parallel axis theorem you can use it now. Moment of inertia of the removed part now, you can rewrite it as Ig. Ig is nothing but a mr square by 18 plus m into, therefore this distance is how much now? 2r by 3. Clear? Therefore 2r by 3 whole square. So how much it will be? Mr square by 18 plus, therefore 4 mr square by 9. So multiply by 2, therefore 8, therefore 8 plus 1. So 9 mr square by 18, that is mr square by 2. This is your moment of inertia of the removed part now. Removed part. Therefore the total moment of inertia of the remaining part now. So total moment of inertia of the remaining part, whole body is how much now? 9 mr square by 2 minus, right? Here we calculated for complete body, therefore 9 mr square by 2. For removed part, no, we got it as mr square by 2. Therefore here mr square by 2. So therefore we can write it as 8 mr square by 2. That is nothing but a 4 mr square. Like this you can calculate the removed part, right, of a remaining body moment of inertia, right? But important is what? For complete body minus total removed part, no. But keep in mind moment axis of rotation for both the situations, no, it should be the same. Clear? So now we'll do one more important question, one more question, no. Let us see. There is a one rod is there, no. This is one rod. This is one rod. So whose mass is m and length is l, and it is rotating here, no. So moment of inertia, suppose it is b I. Therefore, so suppose this is I. Now the same rod, here there is a rod is there. So here moment of inertia is I, ml square by 3. So here this rod, no, we are going to rotate here now. Right? So we want to rotate the moment of inertia I dash, no, it is making an angle theta, suppose 30 degree now. So we want to calculate it, no, therefore I by I dash, this value we want to calculate. So moment of inertia for this one, no, therefore here it is inclined, no, just you can remember one small formula, ml square by 3 into r, I is equals to I naught into sine square theta. Therefore this I naught is nothing but it is rotating here, no, it is horizontally. So therefore here you can take it as like ml square by 3. Clear? Or if you want to derive, no, therefore we'll go for derivation on this one, no. Here we'll take one small amount of mass, no, that is dm of thickness dx, which is at a distance is x, no. So this is at a distance is r. What you can write it now? Sine theta is nothing but a r by x. r is equals to x sin theta. So dm by dx is nothing but a m by l. So we know moment of inertia. So we already discussed this type of questions no, in the part 2. Please go through it. No, integral r square into dm. So r square is how much now? What is r square now? Therefore it will be x sin theta, therefore whole square into dm is nothing but m by l into dx. m by l into dx. So taken here no, m by l into sin square theta integral, therefore x square dx. What is the limits now? 0 to length is l. So you can rewrite it as how much it will be. So m by l into sin square theta into x cube by 3, 0 to l. So that implies m by l into sin square theta into l cube by 3. This will get cancelled out. So what you will get it now? Moment of inertia here. This I dash, we can write down m l square by 3 into sin square theta. Clear? So if you want to calculate I, therefore I by I dash no, therefore very simple one no. So now you can rewrite it as I by, therefore I dash, I is how much now? ml square by 3 by I dash is nothing but a ml square by 3 into sin square theta. Therefore this will get cancelled. So 1 by sin square theta, r. So I by, therefore I dash 1 by sin 30 whole square no. So sin 30 is nothing but 1 by 2. So take and drop no, therefore it will be 4. So I by I dash, it will be equal to 4. Clear? So these are some sample questions no. So one more video we will do it no. So related to the moment of inertia also, some more different problems no, and also we'll go for next remaining other concepts in the next part of this. Thank you. So thank you for watching. Please subscribe to my channel.